This is the agenda for today's discussion. Types of corrosion. Quickly, I'll be touching upon the PREN number, CPT and CCT. What is exactly PREN, CPT, CCT and its importance. And then the product portfolio. And then our new invention that is Sanicro 35, which is bridging the gap between stainless steel and high nickel alloys. And then value addition, how we are giving the value addition to the customers. And then comes another new grade in duplex family. So that is SAF 3006. It is again a super duplex stainless steel optimized for general corrosion resistance. So before going into the topic, let's speak about a fact. So, corrosion comes with the cost. So anyone here knows the corrosion cost? So the global corrosion cost is 2.5 trillion. So every year, 2.5 trillion US dollars is wasted because of corrosion. So I'll be just touching upon different types of corrosion. First one is general corrosion or uniform corrosion. You can see the image over here. So that is the uniform corrosion. So as the name says, it is uniform corrosion. It's like the degradation of material throughout the length uniformly, or you will get the thickness reduction uniformly throughout the length. So that is mainly in applications like acid applications and even in alkaline applications like sodium hydroxide and potassium hydroxide. So that is all about uniform corrosion, and then comes the pitting corrosion. It is again a type of corrosion. As the name says, pitting. So it is like formation of pit. So that is because of damaging the chromium oxide or passive layer in the material. Then it penetrates into the material. So the pit acts as an anode and the surrounding material acts as a cathode. So then the when there is aggressive media, so it will penetrate into the material and there will be a pinhole in the material. You can see the right top corner image. It is a classic example of pitting where you see the pinholes. And then comes the crevice corrosion. So crevice corrosion is again, we can see this type of corrosions in the gasketed joints where the gaskets are bolted in between flanges and tube sheets. So what happens is there is a formation of crevice. Again, the crevice will act as an anode and the surrounding material will act as a cathode. And when the aggressive media is there, then again, it's a type of galvanic corrosion again. So then comes, we have the images there. So this type, we can see in gasketed joints as well as in, baffle to tube sheet configuration, baffle to tube configuration. So the next one is under deposit corrosion. On the right bottom, you can see the image of some under deposit corrosion. It is again a type of pitting corrosion. Why? Because when the salts get deposited in the tubes, like in the OD of the tubes or in the ID of the tubes or in tube to tube sheet joints, so these salts get deposited, and below this deposition, there is a formation of pit again. So it is a classic example of pitting corrosion again. So under deposit corrosion. And erosion corrosion, this is a type of corrosion where, it is a combination of mechanical wear with chemical reaction. So it is like if there is an abrasive fluid or something like that, it is taking away the passive layer of the material, maybe in the ID of the tube or in the OD of the tube. So the material, it becomes like when the passive layer is gone, the material starts thinning. And thinning, at one fine day, the material is opened up, so forming leakages. So then comes the stress corrosion cracking. Stress corrosion cracking is again, you can see the image here, so in the mid. So it is like stress corrosion cracking is again a combination of corrosive fluid with tensile stress of the material. So that stresses may be because of residue stresses of welding or loads, mechanical loads. So you can see the classic image here. So it is like the stress corrosion has started at one point and then it has branched up like a tree branch. Then galvanic corrosion, it is all are well aware that it is an electrochemical reaction where different the materials with the different galvanic cell. If you are using it together, so the material with lower galvanic cell will deteriorate fast. So that is a type of corrosion what we call as galvanic corrosion. So, as you know, in the previous presentation, Jyoti has presented a lot of cases. So, how to avoid these cases? So, like, see, what we say is, while selecting a grade, you should mention all these, like in the specification which comes to the end user, to the customer. So, it should mention all these values like PREN number, CPTs, and CCTs. So what exactly is PREN? So PREN is nothing but pitting resistance equivalent number. So it is like a thumb rule, or I can say it is like a theoretical value which compares the pitting corrosion resistance of the material. So it is particularly useful for ranking of the materials. So it is used to rank the materials, like which material is having higher corrosion resistance and which is having lower. So it is calculated using the formula percentage chrome plus 3.3 percentage, 3.3 times percentage moly plus 16 times percentage nitrogen. So higher the PREN number, higher the pitting resistance. I'll be explaining this with the example. So as Jyoti said, in ASTM standards for any materials, there is a range of alloying elements. So this is an example of super duplex stainless steels, where you can see in the ASTM standard, the chrome percentage is mentioned as 24 to 26, and moly 3 to 5, and then nickel 6 to 8, and nitrogen 0.24 to 32. So if you go on the lower side, like if you use 24 chrome, if you use 3 moly or 6 nickel and 0.24 nitrogen, you'll end up in a PREN number of 37, approximately 37.5. So if you go on a higher end side, like 26, and then go down to nitrogen with the 0.32, you'll end up in a PREN number of 46, 47. So, but we guarantee a PREN number of 42.5. So now there may be a question rising up. So why can't you go for 46, 47? So instead of that, you are giving only 42.5. So see, being an inventor of this material, we know how the stabilization of this material is done. See, this is a duplex grade, again, ferritic and austenitic phase. The phase balance is very important here in this material. To ensure that, see, like chrome and moly stabilizes the ferrite grade, and nickel and nitrogen stabilizes the austenitic phase. So to make that phase balance, you have to use this chemical composition. If you have anything more or anything less, you will not have that phase balance. So that is the reason to, once the phase balance is done, you'll have this pitting resistance number. Higher the pitting resistance number, higher is your corrosion resistance of the material. So, and even the benefits, by using this higher chemical composition, what are the benefits we get? Like chrome and moly will have, higher resistance to localized corrosion. And whereas nickel and nitrogen lowers the corrosion rates in service. And resistance in chloride environment too. Just a quick touch on CPTs. So since morning we are listening about CPTs and CCTs, just I'll be briefing about what is CPT and what is CCT. So CPT is nothing but critical pitting temperature. So it is the temperature at which the material starts pitting. So it is dipped in a chemical. Different test has different chemicals prescribed by codes and standards. So taking an example like ASTM G150, so we have 1 molar sodium chloride solution, or 3 molar magnesium chloride solution, and even 4.5 molar magnesium chloride solutions. So different tests, different solutions, the material is dipped, and every 5 degrees there is a raise of every 5 degrees, and material is checked. If there is no pitting, again increased by 5 degrees. So at one particular point of time, the material will start pitting. So that is called as critical pitting temperature of the materials. So in the previous case, I have discussed about PREN. So if what happens, if PREN is less, so your critical pitting temperature will go down. If your PREN is high, the critical pitting temperature of the material goes high. So which is good when in operating conditions. So your localized corrosion resistance is high. And then comes the CCT. So CCT is nothing but crevice corrosion temperature. Again, it is very similar to CPT. It is again dipped in a solution, but here the crevices are made in the material and then checked at what temperature the crevices are formed. So this is again a very important aspect. So normally what we do is we order a material and the material comes in and it says that it is meeting all the specification requirements. But if there is any, default in the material, so how to find out that defaults? So you can check these three, like, pitting resistance number and CPT, CCT. If then and there you'll get caught, because if he has made any mistakes in producing the tubes, so you'll get the you'll not get the results here, proper results. So these are different corrosion tests. So I don't want to read it actually. So there are different tests. It is for different materials actually. So intergranular corrosion is for austenitic stainless steels, and then ASTM 923 method A, method C is for super duplex stainless steels, and then comes your CPT and CCT for both austenitic materials as well as duplex family materials. So it is, again, the test condition is it is dipped in a solution, and temperature is raised at one particular temperature, the pitting or crevice will be formed. And in super duplex case, it is something different. So that is intermetallic phases. So in ASTM 923 method, method A and method C. So method C is, again, it is dipped in ferrichloride solution, and then the intermetallic phases are checked. So just about Alleima's portfolio. So as Yadavendra in the morning presentation said, we have more than 850 patents. So I've just listed some of the materials here, not all. So out of which we have, austenitic stainless steels, lower grade austenitic stainless steels ranging from 304 to 347. And then comes duplex family, and the grades, what you have mentioned here, we are the inventors of all these grades. So 2205, 2304, 2507, 2707. And we have a new grade in duplex family, that is 3006, which I'll be touching upon. And then in high nickel alloys, so we have a new grade called Sanicro 35. So these two are the highlighted ones, which I'll be discussing in my further slides. And we too have titanium, zirconium, and bimetallic tubes. So bimetallic is mostly we are supplying it for fertilizer applications like urea strippers. So this is already solution specific. Yadavendra has discussed in his slide. So it's like on different applications, the problems comes to us, and then the solution is these materials for that problem. So different applications, different materials. So yeah, coming to the hot topic, so that is Sanicro 35. So it is the material which bridges the gap between high nickel alloys and stainless steel. So this is corrosion resistance versus temperature graph. So what happens is normally austenitic stainless steels will have corrosion resistance, very less corrosion resistance, but it can be operated in wide range of temperatures. So low-grade stainless steel can be operated up to 600, 650 degrees Celsius. So then comes super austenitic stainless steel, which is slightly higher than low-grade stainless steels. So again, the temperature range is wide, and then comes duplex and super duplex, hyper duplex family, where the corrosion resistance is higher with the higher mechanical strength in the material. But the problem is temperature limitations. You cannot use duplex, super duplex beyond 300 degrees Celsius. And then comes high nickel alloys. Yeah, this is ultimate solution, but cost-wise, it's not cheaper. So high nickel alloys is always costly. So we found that there is a gap here. So in between super austenitic, high nickel, and hyper duplex, so we found there is a gap, and that is where it gave up a chance to invent a new material called Sanicro 35. So as we discussed, the pitting resistance. This is a graph where we can see different alloys, pitting resistance of different alloys. So ranging from low-grade stainless steel, where we have a pitting resistance of 18, and then different grades, duplex family grades. Compared to low-grade stainless steels, duplex families is having higher Bren number, and Sanicro 35 is over and above that. So it is having a pitting resistance number of 52, which is equivalent to that of alloy 625, which is having a pitting resistance number of 51. So this is the chemical composition of that material. So name Sanicro 35 came because of 35 nickel in the material. So 27 chrome and 6.5 moly. You can see this. It is a straight austenitic phase, the austenitic microstructure you can see, and you can see the microstructure after 10,000 hours of aging at 550 degrees Celsius. So you don't see any carbides in the grain boundaries. So these are the standards and approvals. So this is already approved in ASME code. So it comes under SB 163 and with the UNS number of N08935. And ASME code, right now we don't have this allowable stress values in the ASME codes, which is there in code case 2982-3. So it is the latest one. So, and the temperature already we got approval up to 550 degrees Celsius in ASME codes. So this is just about the mechanical properties of the material. So Sanicro 35 has mechanical strength of 425 MPa. So higher the mechanical strength, that is yield strength. So it is nothing but you will get higher allowable stresses. So the thickness can be reduced when you are doing thickness calculation, because thickness is based on your allowable stresses of the material. So then elongation, again, it is having a very good elongation of 35%. That is nothing but in comparison with the austenitic stainless steels and high nickel alloys, which is better because having a good ductility, because you have to draw it into tubes, wires, plates. So it is having a good ductility. So we discussed about this. So critical pitting temperature. So we have tested this material with the 3 molar magnesium chloride solution. And you can see at 3 molar magnesium chloride solution, the pitting temperature, critical pitting temperature of this material is 110. So which is very high compared to that of 904L and 254 SMO grades. And with the Pren number of 52 again. So that is the reason you got pitting resistance number of 110 degrees Celsius. So this is again a modified test. So we used 4.5 molar magnesium chloride solution here, and then it is compared with the alloy 625 and C4 G3 materials, which is again high nickel alloys. And you can see the pitting resistance, critical pitting temperature of 89. So very similar to that of alloy 625. So it is incomparable or in par with alloy 625. This is again a pitting corrosion test with 3 different solutions. So 6% ferrichloride plus 1% HCl, that is ASTM G48C. And then in between you can see this green death solution. And the last one is again G150 modified, where the pH is maintained of 5. So 4.5 molar magnesium chloride plus pH of 5. So very acidic in nature. So in all these 3 conditions, you can see there is a comparison of 2 materials, that is Sanicro 35 and alloy 625. So in all 3 cases, it is good than alloy 625 or at par than alloy 625 in all 3 cases. This is Krivi's corrosion test. So this is again as per ASTM G48 with the 6% ferrichloride, and we have done it as per ASTM G48D and F. So G48D is with the low torque and G48F is with higher torque. So you can see there is a comparison between 3 materials here. So that is alloy 625, C276. So in all both cases, it is superior than alloy 625 and in par with the C276 in comparison. So I'll just quickly touch upon the installation examples. So this was one installation happened in Indian refinery. Here it was like a very critical application. There was an instance of 16 leakages in a period of two years. So every time they used to open the exchanger, plug the tubes, and they used to run the plant. So, and it was in hydrogen generation unit, so which is very critical for a refinery. Downstream, if there is no hydrogen, nothing will happen. So it was very critical, and then we suggested using Sanicro 35 tubes, and as of today, it has completed 2.5 years without any failures, without any leakages and outages. So. And the refinery itself has proposed that they have got a life cycle cost saving of 19 crores. And then comes one application that is waste heat recovery boiler in a formic acid plant in Asia. So on tube side it is formic acid plus water, and on shell side it is water plus steam. There are 2 plants running. New plant was operating with 904L U-tubes, which failed within 3 years of operation, and it got upgraded to C22. And old plant was with the super duplex 2507, and it again failed within 10 years of operation. Like they were expecting a life of 20 years, but it was like a premature failure then for them. So then it was selected for a grade upgrade following the good results with installed tubes since 2023 with expected life of 20 years. And it was welded, like Sanicro 35 tubes were used, and it was welded with existing super duplex tube sheets. This is again application of in ammonium sulfate unit. It's in iron and steel desulfurization plant in China. So tube side, it is like around 1 lakh ppm of chloride. So very high chloride plus 4,000 ppm of fluoride. So shell side, it is steam. So it's like 2507 super duplex tubes failed in 1 years of operation. So we have installed 5 tubes in this application, and since seems to be a promising for us. So we are waiting for the results. And you can see this image there. After 30 days of operation, we have installed a couple of tubes of Sanicro 35 along with super duplex. You see, this is the welding. It is very intact, Sanicro 35. And whereas you can see the tube-to-tube sheet welding of super duplex, it is already eaten up. So it is within 30 days of operation. And then this is a recuperative heater plant in a PTA plant. So again in China. So here tube side, it is a catalyst oxidation reactor effluent, and then on shell side it is feed of the catalyst oxidation reactor. So it is like a feed effluent exchanger. And then 316L experienced severe corrosion in the bottom 2 rows. So they they were planning to go with 904L. They tested the coupon, but it still didn't work. And bottom 6 rows was replaced with Sanicro 35, and we are awaiting the results for that. But it's running well, so no outages. This is again a recuperative heater. It's in acetic acid plant. Oxidation reactor unit tail gas condenser, the name of the equipment. And here again acetic acid with bromide catalyst, and on tube side they have not specified the condition. Originally the tube material was 316, the lower 2 rows corroded very fast. And then 904 was tested, and then C27 upgraded to upgradation was considered to C276. Then we have given this presentation like Sanicro 35 would work well in this application. So it was selected for a grade upgrade. So with the Sanicro 35, installed some test tubes there and awaiting the results here. This is in a US Gulf Coast refinery. So this is the oldest installation. So it was installed in the year 2020, so 5 years from, back now. So it was like previously they were using super duplex and hyper duplex materials there. And due to refineries increasingly challenge, process conditions, and retubing was called, and then Sanicro 35 was, we have evaluated the condition, and then we have suggested to use Sanicro 35, and it is running since past 5 years without any failures. This is again a FCC unit, again in an Indian scenario. So it is super duplex tubes was used, and they faced a failures within 8 to 9 years. Again, premature failure. They were expecting a life of 20 years. So it was because of stress corrosion cracking. They were using seawater on one side, and other side it is debutanizer overhead. And then it was installed with Sanicro 35, 1 tube pass, and then it is running since 2022 successfully without any failures. So how we can give value addition? So I can just give you an example of a return on investment calculation. So this was for one refinery application, and I have one more for chemical application. So here it was like, it is a comparison of carbon steel. So, very good example here. So the carbon steel tube cost is somewhere around 22 lakhs. But that 22 lakhs is creating a problem of 2.9 crores. That is because of shutdown of the refinery. Very critical, because this is the application where the refining of the crude starts. So CDU or red condenser. So CDU is nothing but the column, CDU column, where the crude goes in and it differentiates into different components. So if this gets shut down, so entire downstream will get shut down. So the losses they were making is 2.9 crores, but they were using carbon steel there, which the replacement cost is somewhere 22 lakhs. So we gave this return on investment calculation where they're getting a return within 1.5 years if they are going with Sanicro 35 tubes. So it is under consideration now. And this is again a comparison with the duplex stainless steel. So here the maintenance cost is, I have not considered any maintenance cost on both sides. So it is the duplex steel on left side, and on the right side you can see Sanicro 35. So Here it was like a mechanical vapor recompression, MVR in Calentria, so which Jyoti also discussed. So here it was like the tube cost is somewhere around 8 lakhs, and then maintenance loss is again around somewhere, fabrication cost is 8 lakhs, maintenance loss is zero. So on both sides. So here the return on investment will be somewhere around 2 to 2.5 years. So this is the additional value addition what we do to the customers. We give the return on investment calculations. So this is again a new grade. So this is a super duplex stainless steel optimized for general corrosion resistance, SAF 3006. So SAF is nothing but Sandvik austenitic ferritic steel. So this is again duplex steels, duplex family will give you a very high pitting and crevice corrosion resistance, mechanical strength, higher chloride stress corrosion cracking resistance, thermal expansion close to carbon steel. So often, optimized for high chloride resistance, and therefore the performance of duplex steels are very good. So now what new we are adding up? So we are adding the additional benefits. So that is nothing but all the benefits traditional of duplex stainless steel families plus optimized for general corrosion resistance in acid applications. So this is again the chemical composition. So 30 chrome and 7 nickel. It is 6 point some nickel, so it is rounded off to 7. So 3.2 moly. And this is again, we have got the approval with in ASME codes with the UNS number, S83071. So it comes under SA789 again. Again, this is a balanced composition with the good microstructural stability. These are mechanical properties. So if you compare this with any other material, so you have very high mechanical strength for these materials. So for this grade, it is somewhere around 680. So in comparison with duplex, 2507, super duplex, it is 550. So in comparison with that, it is having very high mechanical strength, and even a tensile strength of 830 MPa. And pitting corrosion resistance, we can say it is equivalent to that of super duplex 2507. So with the 75 degrees, and with the ASTM G150 test, it is 87 degrees, slightly higher than super duplex. So this is in comparison in different medias. So taking 2507 as a reference line. So that it is mentioned as 00. So that is the reference line in comparison with super duplex. So how this material, so that is 2707 is a hyper duplex material, and this is a new material 3006. So this is having added advantages in all applications like hydrochloric acid, sulfuric acid, and formic acid, sulfuric acid with higher chlorides, and then nitric acid, sodium hydroxide. So, and even in pitting resistance, it is having an advantage. So applications, so where normally this material is focused for all acid applications, nitric, hydrochloric, sulfuric, and then caustic evaporators and organic acids, and as well as in the refinery condensers. So coming to the end, actually, so see, Alleima's commitment to safety and innovation and value addition empowers the industries to operate with confidence and sustainability. With innovations like two different grades, Sanicro 35, which is bridging a gap between high nickel alloys and stainless steels, and 3006, a new material for the duplex family, which is used for optimized general corrosion resistance with higher mechanical strength. So advanced corrosion testing, as we discussed, so that is very much important. So when you are buying a material, so you should know what you are buying. So normally what happens is you are just giving a code reference and you are asking to get a material, and we are getting the material, and once it is in service, you are getting premature failures, leakages, outages, which is a costly affair actually. So before procuring the material, you should mention so what you want. So I want a print number of this and this. I want a CPT of this temperature. I want a CCT of this temperature. So if you're mentioning that, you're getting a proper material. So, and a good material which will long last. So prevention is better than cure. So, so you have to prevent it at the right stage. So thank you.